Question number 3. In this question, we will have 3 charges arranged in a triangular arrangement. So you're going to see 2 charges on the x-axis, 1 charge on the y-axis. You need to find the net force on the y-axis charge, as well as the direction of that net force. Again, I'm going to use this as an opportunity to provide you an example. Try to use that as a template to work your problem with your values. Okay, let me go ahead and begin mine. Let's see, I have a charge 1 at, looks like 5, 10, 15, 18 boxes from the left. That would be here. So there's Q1. I'll write it up here. That's Q1, and that's negative 239 nanocoulombs. Q2 looks like it's 9 boxes away from the origin to the right. That's Q2, and that would be positive 698 nanocoulombs. And charge 3 looks like it's 14 little boxes down on the y-axis. So 5, 10, about right here. Okay, and that's Q3. That's a positive 560 nanocoulombs. Okay, so one of the things that we will need to do is we will need to find the distance between 2 and 3 and between 1 and 3. We need to find these distances because to use Coulomb's law, we're going to need the distance between those charges. So in order to find those distance, I'm going to make a little blue triangle here to establish this pair of charges. Okay, and you can see clearly that the top distance right here, remember every single box is 0.1 centimeters. So we're looking at, let's see, 5, 10, 15, 18. That would be 1.8 centimeters. And then this is about 1.4 centimeters. Okay. And the gray box, I'm going to make a gray triangle over here to represent these pair of charges. This one would be 0.9 centimeters, and this is still 1.4 centimeters. Okay, so I'm going to quickly use Pythagorean theorem to find the distance between. Okay, so starting with the blue distance, which would be the distance between charge 1 and charge 3. And that looks to be about 2.28. Okay, and the other distance, about 1.4 squared plus 0.9 squared. And then we're going to go ahead and square root that. And I'm getting about 1.66. Okay, about 1.66 centimeters. Okay, so I've got my distances, all right? And now what we're going to do is we're going to take a look at the charge interaction between, let's say, charge 1 and charge 3, and then charge 2 and charge 3, okay? And that's based on the sign of the charges. So I see that charge 1 is negative, charge 3 is positive, and that means charge 1 is going to pull charge 3 kind of upward in that direction. Okay, so I'm going to call that F13. So I'm looking for F13 in this step here. So I know F13 is going to be pointing up in this direction here. Okay, I got to find its value. And I can find its value by using Coulomb's law, F equals K Q1 Q3 over R squared. But once I find that, I'm going to need to find its vector components. Okay, so to find our value, we'll plug in 9 times 10 to the 9. Now for me, charge 1 is negative 239 nanocoulombs, so I'm going to put in 239 times 10 to the negative 9. And charge 3 is 560, so 560 times 10 to the negative 9. Okay, and the distance between charge 1 and charge 3 is 2.28 centimeters, so that would be 0.0228 meters, and then we got to square that. Okay, so at this moment, go ahead and pause the video and enter your values for charge 1 and charge 3 into Coulomb's law, and let's figure out the electric force, force 1, 3. Now for me, I get about 2.32 newtons. Okay, so that's the hypotenuse here, 2.32 newtons. Now, in order to find these components here, the horizontal and vertical components, I need the angle theta right here. So I got to figure that out. Well, theta is the arctangent of the y component, this distance, over the x component, that distance. Well, the y component distance is, let's see, 1.4 over the horizontal component, which is 1.8. So if I take the arctangent of 1.4 over 1.8, I get about, this angle here is about 37.9 degrees. Okay, so that's my angle. Okay, now to find these components, I'm going to go, this component here is going to be F13 in the x direction, and that's equal to my vector magnitude, which was 2.32 cosine of 37.9 degrees. I'll put that in my calculator. Okay, I'm getting about 1.83 newtons in the x direction. And now technically it's going to be negative 1.83 newtons because you can see this vector is going left. So I do have to account for that negative. Now the positive one is going to be F13 in the y direction. And that is going to be 2.32 times the sine of 37.9. Now for this, I'm getting about 1.43 newtons. So pause the video at this point and figure out your x and y components of F13. Okay, now we're going to find F23, and we're going to find the x and y components of that one. So now F23, what's going on? Well, 2 is a positive charge, and it's going to push 3 down and to the left. So I'm going to draw that. I have a vector pointing down and to the left. This is going to be F23. Okay, and for this, I've got components that are going essentially to the left and down, right? And this is going to be the direction, the angle theta right there. So F23, let me just kind of move this over to the side right here. Okay, F23 in the x direction. Okay, and this is going to be F23 in the y direction. So let's find what F23 is. Okay, here's F23. And it's going to be K Q2 Q3 over R squared. Go ahead and plug that in, 9 times 10 to the 9. Now for me, my charge 2 is 698 times 10 to the negative 9 coulombs times charge 3, which is 560 times 10 to the negative 9 coulombs. All of that is going to be over the distance between charge 2 and charge 3, which we found earlier to be 1.66 centimeters. Now, you got to put that in meters, of course. So that's 0.0166 meters, and we got to square that. Okay, at this point, go ahead and pause the video, and let's figure out your F23. Okay, now for me, I got about 12.8 newtons for F23. Okay, now it's pointing down and to the left, which means my F23 is going to be negative because it's going left, and my F23x is going to be negative, and my F23y is going to be negative. So I'm going to go 12.8 cosine. I got to find these angles, right? This one's going to be 12.8 times the sine. Now, what is this angle theta right here? All right, we can find that. Angle theta is, well, the arctan of the y component, which is 1.4, over the x component, which is 0.9. That would give us this angle right here. Okay, so the arctangent of 1.4 over 0.9, in my case, this angle is going to be about 57.3 degrees, okay? You should take the time to find your angle theta too. So times the cosine of 57.3 degrees, and then times the sine of 57.3 degrees. So F23 is going to be negative, so F23y is going to be 12.8 sine 57.3, and that's going to be negative 10.8 newtons. Okay, and this part here is 12.8 cosine 57.3. That's going to be 6.92 newtons. Now it's going to be negative because that one's also going to the left. All right, so at this point in step 4, we have to find F in the x direction and F in the y direction. So we get that by adding the x components of 1, 3, and 2, 3. And to get the y component of the net force, we add the components of 1, 3 in the y direction and force 2, 3 in the y direction. So F13 in the x direction is negative 6.92 plus F23, oops, sorry, that is F23. Let me back this up. F13 in the x direction is negative 1.83 plus F23 in the x direction, which is negative 6.92. So that would add up to negative 8.75 newtons. Okay, in the y direction, F13 in the y direction is 1.43 plus F23 in the y direction is negative 10.8. Okay, so if we add those together, 1.43 minus 10.8, or plus a negative 10.8, is negative 9.37. Now, if you put that into consideration, what that means is your x component is going to be a certain distance, 8.75 newtons, and your y component is going to be just a bit longer. Just a bit longer. Such that if you put together your parallelogram, your net force is going to be that much, and your angle is going to be that much. Now keep in mind, the angle we have to take from 0, so we're going to have to take this angle plus 180. Okay, we'll get to that when we get to that. So the first thing we're going to do is we're going to use, since we're looking for the net force, which is the hypotenuse here, we got to go this side squared plus this side squared equals that side squared. Pythagorean theorem, guys. So F is equal to the square root of negative 8.75 squared plus negative 9.37 squared. This is our net force. So 8.75 squared plus 9.37 squared, square root that, and we're getting about 12.8 newtons, okay, of net force. To get the direction, okay, we're using the arctan formula again. So it is the arctan of the y component, negative 9.37 over the x component, negative 8.75. 9.37 over 8.75, take the arctan of that, and we're looking at about 46.96 degrees. Got to add that to 180, because remember, we saw that our vector is going down in quadrant 3, so we got to add that to 180 degrees to take it to 0 degrees, or to take it from 0 degrees. All right, so our direction would be about 226.96 degrees. Go ahead and check that. And there we go. Okay, so I was able to do this one correctly. I hope that you were able to do this correctly as well.